Okay, I want to talk about impulse and momentum and how they're related. Impulse momentum theory. You saw this already, but think about it this way. If an object is moving to the right at a certain speed, like 2 kilograms at 3 meters per second, and you give it an impulse, you need to apply a force to it. So it takes a force to change the speed. And when you change the speed, you change the momentum, which is just mass times velocity. And since impulse is a change in momentum, when you apply a force, you also apply an impulse. So the impulse equation says this. J is equal to force times time, which is equal to the change in momentum. So when you see impulse questions, they're the kinds of questions that will often include a force and a time in it, or asking you to calculate one of those. So let's say, for example, a 2 kilogram box comes to rest over a period of 2 seconds. What's the force? Well, you can apply impulse momentum theory to figure it out. Usually what happens is you have something changing speed. Sometimes it's balls being kicked too, and there's a force and a time involved. So we don't even need to calculate the impulse. We don't know the force. That's the thing we're trying to find. But we do know that time is 2 seconds. And we know the change in momentum is mass times velocity final minus mass times velocity initial. But if the velocity doesn't change, it's just v final, which is 0 meters per second, minus v initial, which is 3 meters per second. So you end up getting force times 2 seconds equals -6 kilogram meters per second. So that would be your impulse, -6. And so your force would be -6 kilogram meters per second divided by 2 seconds. So you end up getting -3 newtons is your force. These kinds of questions, you're going to have force and time involved in them most often. There's a different class of momentum questions I'm going to talk about separately. So let's think about this though. This would be like an object coming to rest slowly. What if instead of coming to rest over a period of 0.2 seconds, the same thing crashes into a wall and comes to a rest over a period of 0.2 seconds, a lot more quickly? Well, this time, force times time, 0.2 seconds, equals the same impulse. So you have the same impulse because you had the same change in momentum. It still started at the same speed, ended at the same speed, which was 0. So you have the same impulse. The difference is that your time is different, 0.2 seconds. So now your force is 6 kilogram meters per second divided by 0.2 seconds, or -30 newtons. So instead of 3 newtons, it's now 30 newtons. So it just goes to show that decreasing the stopping time drastically can increase the force acting on an object. And that's one of the cool things that comes out of impulse momentum theory. The negative sign just means that it is pointed in the negative direction. So if the object is moving to the right, that means that your force is to the left, and that's what's causing it to slow down. Thank you very much for watching.